This is the CountryMod 12-volt DC air conditioner, and today we're going to be taking a deep dive into this product and finding out if it actually lives up to the hype. Welcome back to Morton's on the Move, and welcome back to the shop. I love testing new products, and today we've got another unique one. I've tested quite a few RV rooftop air conditioners, but this will be the first 12-volt unit we're featuring on the channel. Now, we are not new to 12-volt DC air conditioners. In fact, we've been running a Dometic RTX 2000 on our truck camper for about 4 years now, and it is amazing. If you are more than 50% of the time off-grid in your RV, I would definitely consider using a DC air conditioner if you're trying to run air conditioning off of solar panels or your batteries. Our Dometic RTX has been a mind-blowingly efficient unit, and I'm excited to see if this thing can match or get near the performance of that unit. This CountryModPro sells for a fraction of what many of the air conditioners of the past have, and I'm excited to see how it performs. Part of the reason this is so cost-effective is this is a direct from China product, and it is pretty generic overall, but it doesn't mean that it performs poorly. I'm going to put a disclaimer right up front here, though, that I was not able to find any certifications on this product, UL, CE, or otherwise. So use the product at your own risk. Hopefully by looking into it, we'll be able to glean whether this is a safe product or not. Now, DC air conditioners are designed to run directly off the batteries, no inverter required. So for solar-powered applications, these are going to be way more efficient. However, if you spend most of your time plugged in, running one of these units is going to require a conversion from the AC system. And even though they typically feature higher efficiencies, you might lose a lot of that efficiency in the conversion process and put additional stress on your battery charger. So whether you choose to use one of these or not, I think is going to depend mainly on how much time you spend off-grid, or if you're trying to offset some of your power use by your solar power system. I've seen a lot of people start switching out maybe their second air conditioner to a DC, so they kind of have the best of both worlds, an AC and a DC unit. And maybe this one can run on the solar power system, where the other one runs on the grid, even lessening your power consumption. Now, this unit has been a hot commodity, or at least appears so, as CountryMod has been sending this to a lot of people for reviews, and they even provide a brochure with it that offers I don't know, a gift card or a discount if you create a review for it. So that's probably partially what's driving so much interest in this. Because they sent me this, I will go ahead and mark this video as sponsored, but as a disclaimer, I always give manufacturers when I take a product, I am going to give my true and honest opinion. I'm not obligated to say anything specific about this product, and it's truly unbiased as I don't even need this. I already have a 12-volt air conditioner. I'm just testing it out for your benefit. Now, before we make any other assumptions about this unit, let's go ahead and just start taking it apart and taking a look at it. Then we'll run it here in the shop to actually test its actual performance. Now, this unit may look huge because I'm filming this on a wide angle lens and it's in front of me really big, but it measures about 32 inches wide, which is pretty wide, by about 31 inches long, so about square, but amazingly only about 7 inches tall. Now, that's not including the gasket we're going to have to put on the roof, so it's going to be a little bit taller, but this is a very low profile unit, which is pretty awesome overall. I think people like the look of these low profile units. It of course reduces your overheight clearance. This unit's also incredibly lightweight. I think it comes in around 57 pounds, and it's actually pretty manageable for one person to pick it up, which is pretty cool. It uses a traditional split design, meaning the interior unit or the air distribution box is a completely separate piece, and it basically sandwiches into the roof. A lot of 12-volt air conditioners, like the Dometic RTX, is a single unit that actually has a piece that sits down through the roof and then a shroud that covers it. This two-piece design kind of allows to fit larger, thicker roofs possibly, and it does have this little air distribution portion here that can expand to fit slightly deeper roofs, but it only goes up to, I don't know, 4 inches or so. So you're probably going to have to modify it if you have a thicker roof on your RV. Our truck camper's roof is only about 2.5 inches thick, so this is going to fit just fine. A neat thing about this air distribution piece, and we'll take a look at this once we get it installed, is that it actually has louvers that swing back and forth, similar to like a mini split design. There's little motors at both ends, and it ejects the air forwards and backwards, which I really like, particularly for our use case. But depending on how you want to distribute the air, this is pretty neat. It also has sound dampening foam inside the area where the air drops down to be ejected. We'll take a look at that interior portion, how it actually functions later. Let's open this thing up and take a look inside. All right. So this thing feels pretty thin. It's pretty flexible. for the shroud. But one thing we can immediately notice here is that the shroud is not required for airflow. This air distribution unit, gosh, this looks almost identical to an automotive fan and automotive radiator. This is pretty much the same as what you're going to find in a DC powered car air conditioner, which is pretty cool. But that shroud has nothing to do with the airflow. So that's kind of nice, because even if it were to like get hit and crack or something, this unit should still perform well. So let's start with this compressor here. This is a pretty interesting design, different than what we've seen before, in that it is connected with braided hoses. And this is something generally we'd consider to be less robust than a welded copper. However, this is kind of a neat design in that if this compressor is vibrating, it's not going to transmit that vibration into the unit, because the whole thing sits on rubber blocks, and that's pretty cool. This is, as the rest of the unit goes, extremely generic compressor. I was not able to find any information on this. However, they claim it to be a dual rotary inverted design, and this is a 12-volt unit. And you can see the big wires going to it. So this actually operates at 12 volts, which is pretty crazy. And that allows us to use really small electronics that are just basically varying the 12 volt to all the components. We're not actually converting them. So that's probably where we get a lot of the efficiency out of this unit. If this is a true dual rotary design, it's also going to minimize the noise and vibration of this unit, because the two rotary cylinders basically offset each other. And this is usually a more expensive compressor design to use, but if it's a truly twin cylinder, this could make this compressor very quiet and very low vibration. And then add in these flexible lines, and that's a pretty awesome setup. Now, you might be worried about these flexible lines and their potential to fail. Yes, but we have lines like this in our coach that are 17 years old, running 45 feet, and we haven't had any trouble with them. I've also got a backhoe that is 45 years old and still running 2,000 PSI hydraulic lines that are still working. So they don't necessarily fail. It depends on the quality of the unit. Looking at the fan here, this basically looks like a same type of fan that you would find in an automobile cooling system. It's probably just a 12-volt brushless fan stuck onto the evaporator unit. Now, a lot of you have expressed concerns about this fan being pointed straight up in the past. We have multiple air conditioners that have this design, and it's really never been an issue. I think I got a stick in one time. Rain, even snow hasn't been an issue. This won't be operating in snow, though. This is not a heat pump. So generally not a problem. I do like this fan design in that it's got the kind of curved blades that should quiet it down. It's probably going to sound a lot like a car running its air conditioning fans. Let's go ahead and open up the air box here and take a look at how the air on the inside portion moves. This is basically the outside air, and this is the inside air. With the interior air portion opened up here, we can see it's really a pretty simple design. Air comes up through this space here. Our wiring and everything goes down into the RV here, through the evaporator coil here, and then this little tiny, this is a centrifugal fan. So the air basically goes in and down, in and down. I did notice that because this fan is so off-centered, the air box sits right up against this side. So this fan is going to be far less efficient than this one over here. Once again, we have a little tiny 12-volt motor, 3-amp 12-volt motor for the interior airflow. Overall, this is a very small, compact interior unit. This interior coil is basically a double block, so it's a higher density. So we should see some pretty extreme temperature drops on this small unit, which hopefully will help with its dehumidification. Looks like water is going to come out and either go to the front or down this channel to the back of the unit. Now, one thing I'm going to do while I have this open is I'm actually going to cut the zip tie here and move this power input line, I don't see any reason we can't do that to exit out onto the roof. If your RV has the power run in the ceiling, then this is a great way to do it, but we already have power on the roof for our existing unit, so I'm gonna go ahead and move those lines to the exterior. A couple other technical things of note. I have no idea how they are metering the coolant flow. It appears like it just comes down, no capillary tube, just directly into the evaporator. We've got quick connects on the compressor, which is kind of cool. These are basically the same that we see in automotive systems. So literally, I think this is basically straight out of an electric car. These mean that this could be replaced relatively easily, and interestingly, it has a charging port, an actual port on here. So in theory, this could be recharged easily if it were to need a compressor replacement or to be topped off. Being that this is R32, however, it's not going to be the same as charging up a car air compressor. It'd be interesting to know if it could run on 134. Now this control panel, how generic is that? It comes with it, actually detaches and came separate. It has a temperature sensor and 2 plugs that you have to go ahead and plug in. We will actually go over the operation of this once we get it fully installed. But for now, I'm just going to go ahead and plug it into the unit so that we can run it here in the shop. Just looking at it real quick, you can see it's IR sensor there for the remote that's included with it. I am not sure what that little thing there is. Oh, the beeper, maybe? I don't know. Oh, beeps. I hate beepers. I'm probably going to go ahead and disable that beeper. Anyway, this unit's going to be mounted up on the air distribution underneath it when we get it installed. So there is a beauty to the simplicity, and I'm hoping that translates to efficiency and performance. Let's go ahead and put it all back together and fire it up. As I move these cables here, these don't have any information on them. They appear to be about 4-aught, or not 4-aught, 4 gauge, which should definitely be able to handle the loads that this is rated at. I will say that their terminal connections are relatively small, and it does come with an entire set of wires, which is pretty awesome for running down to your batteries if you're going to add this into your system. To add a 12-volt air conditioner, the wires are so big, they're hard to usually run in the ceiling or walls, but a really easy way to do it is to find a different path, in our case the refrigerator on the truck camper, so we just ran them on top of the roof. Now, that's why we're going to exit this here. This does have these like fuse-like things that are rated at 150 amps on the connection of the wires. I also wouldn't trust what they provided for your over circuit protection. Please use well-reviewed certified safety products for your power system. We're going to be fusing this off of our Lynx shunt with, I believe, a mega fuse from Bus. So that's what they provided. It's not terrible, but I would recommend a little bit of an upgrade on the wiring system. Okay, so changing the wire position is extremely easy. One other thing, if you choose to run these on the roof of your RV, definitely make sure they are shielded. These are probably not sunlight resistant, and I can guarantee you that they will get destroyed in the sun if they are not. Sunlight does a number on cables, and I've even seen fires because people did not use sunlight resistant PV wires on their roof. So one way to get around that is to shield them, cover them in something that will basically protect them or degrade in its own right. But do not leave non-sunlight resistant wires out in the sun because the jacket will corrode and the wires could short out eventually. Putting this back together, I will say I'm not a huge fan of this. This is just straight polystyrene. It even smells a little bit like styrene still. But I mean, it works, but it's basically just cheap cooler material. I'd rather see that with a slightly higher foam. All right, we got it all hooked up and the power cables are now in the position that I want. We're gonna go ahead and hook this up to a 12-volt battery. Yes, just one Battleborn battery over here. We're running that through a PowerBond ThornWaves shunt to pull accurate data off it. And then we are going to take airflow with a Testo 405i. This also can take temperature, so I'll be able to verify the temperature sensors that I'm choosing to use for this are Third Reality, both temperature and humidity sensors. We're going to be taking not only the temperature drop, but the humidity on this as well to get total enthalpy of the unit. They claim this unit rated at 10,000 BTU. Again, that rounding is a little weird to me, so we'll see if it makes it. 270 cubic feet per minute airflow with an EER of 12, which is pretty awesome, but I expect / hope to see that because the Dometic makes an EER of 12 at its highest run and goes as high as 17 in its lowest, most efficient eco mode. And that is mini split territory efficiencies. I'm hoping that we're going to see that on this as well. Let's go ahead, get it hooked up and run it. Connecting the unit. 1.7 watts. All right, so this does draw some power just to keep its brains alive.
All right, let's turn it on and listen to it. We've got a calibrated microphone on here. Let's go ahead and put it into cooling mode, 64 degrees. That should do it. Oh, spin it up. Sounds very much like a car air conditioner. You hear the compressor coming on. Very low vibration. Almost no vibration. And we got cold air already.
All right, this is a little weird, but the sensors are right here and the airflow is going directly through the sensors. I'm going to let these two units stabilize and then we're going to start the run. So we'll have humidity and temperature out, humidity and temperature in. We'll take real airflow as it's running with our meter, and then we'll take power and we'll be able to calculate everything about this unit. I've calibrated these units across the temperature range we'll be running. They are within 3% accuracy from what I've been able to determine. So my numbers here are going to be 3%. This is probably going to be a wider range. I'm going to guess like 6% just because I don't have really good way to get super accurate airflow. So I'm going to say these readings are probably going to be plus or minus 10% of true accuracy. All right, I'm going to go ahead and take a bunch of different data points, and then we'll come back and talk through how it performed. All right, the results are in. This took quite a bit of calculation. We took into account the density of the air, the temperature, the humidity we took into account in this one because it is so incredibly humid in here that almost half of the energy that it was putting into the system was actually removing humidity, and that's called latent heat. So drum roll, the total BTU that I saw off this unit was 8,758 BTUs, 4,017 BTUs of sensible heat, dropping the temperature of the air, and 4,000 BTUs of latent heat, or removing the humidity. And I mean, in an hour of run, I probably got a good half a gallon of water here, and I ran it for an hour on this single 12-volt battery and only drew it down about 50%. So that is just awesome. Now that is at a airflow CFM of 230 CFM from what I was able to measure off this unit. They claim 270 CFM, and if I did change my calculations to 270, it comes out at 10,200 BTUs, but I just did not see that much airflow. But even at the 8,700 BTU, the power draw on the unit was 726 watts, and the EER then comes out to a solid 12.06, and they claim this to have a 12 EER, so we are right there with their EER. This really can't be a 10,000 BTU unit if it has an EER of 12. So I think its actual BTUs are closer to 8,700, and that is actually right in line with what I guess this compressor is. Again, there's no information on this compressor, but I did find a R32 12-volt compressor that had a rating of about 2,500 watts of cooling capacity, which is right in line with where we're at. So I think I can confidently say within a 10% margin of accuracy that this thing makes about 8,700 BTUs, which is really good, especially at that 12 EER. That is amazing efficiency. Of course, being DC, there is no reactive load on this. That is true power directly off the system. That is the max that you will see, 726 watts. That was in the strong mode, full blast, as hard as it would go. I put it in eco mode, and that dropped its power use down to 523 watts. It also dropped the fan down a little bit, running at 190 CFM of airflow. At that mode, I calculated 7,254 BTUs of cooling, bringing it to an EER of 13.8. Wow, that is efficient. And then I dropped it down even more. I ran it as low as I possibly could, basically letting the temperature sensor get cold so that it kept on ramping down, ramping down, ramping down. And it would ramp down to about 364 watts. That's as low as I could get it to run before it shut off the compressor. It'll start cycling the compressor at about 364 watts, which isn't as low as I've seen before. Our Dometic unit will go down to about 120 watts. I mean, just barely humming along. So this definitely shuts off a lot earlier, but still 360 watts is pretty low overall. At that 360 watts, I was seeing a BTU of 5,523, still close to that 50-50 sensible latent heat because it is so incredibly humid in here. But that gave us an EER of 15.17. We're getting close to mini split territories in efficiencies here. When you run this thing low, that is what we generally see with these variable units. When you ramp them way down, they get way, way more efficient. So running it as low as possible and continuously instead of cycling them on and off gives us those crazy efficiencies. Thinking about the efficiency as well, this unit does not convert the power at all. It's just modulating that 12 volts to run that compressor. I think that's probably partially where we're getting a lot of our efficiencies. We're not converting it to a high voltage DC bus. It's not an inverter circuit, if you will. It's just a true variable speed circuit. So very, very few electronic conversions going on in here, just modulating that power flow. Now, the last thing to do is actually install this on an RV and test it out in the real world. All right, we got the unit installed. If you follow our channel, you probably noticed this is not our RV. We had some friends come and visit whose air conditioner was actually dying, and since we already have a working 12-volt unit, we decided to gift this to them. So we installed it on their RV, and overall the installation went really well. Installing the wiring was a little bit tricky because if you're retrofitting one of these units, you're gonna have to figure out how to run that 12-volt wiring. We went down the back of their fridge. That's how we did it on our RV, and it worked really well, but that can be a little bit challenging. Their roof is about 2 inches thick-ish, and that was actually too thin for this unit. We did have to trim down the air distribution portion that sandwiches in here to get it to work, and a few of the screws that came with the unit also weren't long enough to actually connect this piece to the piece up in the ceiling, which was a little bit weird, so we had to find some additional screws. So a few modifications you might have to make to get this to work, but now that it's installed, it is working extremely well. The fan is on this unit right now, and it is really quiet, like really quiet. We took some sound measurements at about 3 feet away as we usually do, and I'll show those to you right now. Overall, this unit is a lot quieter than the Dometic in our rig, and it's just a nicer tone as well. You cannot hear that compressor start up like at all in this unit, which is really awesome. It does have quite a beep on the control panel when you turn it on and off, and we did cover that with some tape, but it's still pretty noisy. If you really don't like beeps though, because this is removable, you could probably pretty easily disable that beep. When we first turned it on, it did have a little bit of that kind of styrene smell because that internal air box is using that polystyrene like we mentioned before. So I would definitely recommend running the fan for an extended period of time with the windows open, just to kind of let it off gas before you plan to really close up and use the unit. Now, like most of these units, the IR controller really has to be pretty much directly underneath it for it to be able to get the signal from the remote, which is a little frustrating. And you do have to use the remote to actually turn on some of the features, like the swing mechanisms here. The only way to do that is with this remote. These swing mechanisms are awesome, and they actually work really well to distribute the air, but they do actually make some noise. They kind of, you can hear it, you can actually feel the vibration. They're just using, it looks like, I don't know, maybe stepper motors, brushed DC motors in there. And they also kind of creak a little bit. Not my favorite design for these functionality wise though. They're awesome and they do distribute the air, but you can turn off that swing, point it at whatever direction you want. It drops the air down pretty well, and it throws it forward and backward. Like we mentioned when we took it apart, it definitely throws a lot more air. I'd say about 2/3 of the air comes out the back of the unit than the front. And that is because of that air distribution design that we saw when we took it apart. From an efficiency and operational standpoint, it's been working basically as well as we saw in the shop. It does an excellent job cooling and dehumidifying, particularly in this Lance truck camper with a single slide. It's managing to maintain the temperature really, really well. The sound is a big part to me. I just love the tone and the sound this thing puts out. It's really a pretty fantastic unit. During the installation, don't expect a lot of help from the manual. It was really generic and didn't really make a lot of sense. Luckily, we've installed a lot of air conditioners before, so it's really the same as most other RV air conditioner installs. So you'll be able to kind of intuitively figure it out, but plan to kind of stumble through it a little bit. Now, the way I moved the wiring to the outside of the unit works flawlessly. We actually made the connections underneath the shroud so that the wires just come out onto the roof and go down. But if you had room in here, we were originally trying to figure out if we could get the wires through the ceiling somehow, but we just couldn't make it work in here. So onto the roof they went, and that works just fine. One thing that is missing on this is some ability to have an auto shut off. Like say you want to run it for 6 hours or something. It doesn't have anything like that, and that's pretty common on most air conditioners these days. It also doesn't have any Wi-Fi or Bluetooth to be able to connect to it via like a phone or integrate it with any other systems. You could probably use an IR blaster to control it. There are a number of products out there that can control mini splits this way, so you could put it somewhere underneath it and control it. But it doesn't have two-way communication or feedback, and I really like to know that it has actually received the signal. So that's something it's missing, but again, at its price point, I guess I wouldn't expect that. The price point that this is at is really economy, and for an economy unit, it does really well. You're definitely getting a lot of bang for your buck here. It's not as well built or high quality as other units that I've seen, but I don't necessarily think that it's going to be any less longevity. In fact, the simplicity of the design in the external unit could enable easy replacement of the compressor or the condenser unit out there, which is pretty wild. You rarely see that in units like this. Because they're such generic products, they might be repairable with something that isn't exactly like what it came with anyway. The electronics on the outside are pretty basic as well. Again, I have no idea if you're going to be able to get replacements for that, but I'm guessing that because this is a pretty common design, we probably could even replace the electronics if they crapped out on this thing. Like I mentioned at the beginning, I couldn't find any listings for this unit. It's a pretty generic unit, so you're taking a chance at that, but I think overall it's well designed. I'm not concerned that the thing's going to catch fire or anything like that. I believe it is running R32, which is technically a flammable refrigerant, but again, because of the way these work and that it's all outside, the R32 never really concerns me. I'm not really concerned with flammable refrigerants because you have to contain them in a very small space to actually get flammability, and R32 isn't even the most flammable out there. Believe it or not, propane makes for a great refrigerant and is possible to run in these units. If you want to talk about flammability, that would be a far more concern than R32. One thing that was a little surprising, this thing says it has a negative ion thing, and when you press it, it actually does something. It shows a little H on here. I don't know what that means. I'm not a fan of these things adding negative ions. I don't know, that could like ozonify. Weirdly, on the controller, it shows a little tree icon, and on here it just shows a little H. I don't know what that is. Is it adding ozone to the air? I mean, that can be dangerous. So I'm not going to recommend you use the negative ion feature, but if you feel strongly about that, apparently it has it. I didn't see anything inside it that would indicate that it's like injecting a high voltage or anything, so I don't actually think it does anything. Interestingly, it shows the R32 weighted at 500 grams in the 24 volt unit and 440 grams in the 12 volt unit. I'm guessing it's just because maybe the compressor size is slightly bigger in the 24 volt unit, even though it claims it to be rated at 10,000 BTUs. Although it didn't quite make it to 10,000 BTUs, it got close enough that I'd say it makes sense that it's within that range, upwards of 9,000 BTUs actual capacity. It does have the ability to turn the display off from the remote, which is really nice as well. We always want to be able to see the ability to turn the beeps off, which you really can't in this unit, but also turn the lights off so that they don't, light up the room at night when you're trying to sleep. This thing makes such a great sound though that, I would just leave the fan on all the time for sleeping and then let that compressor cycle on and off as needed to keep the space comfortable. It's going to vary wildly how much battery power this actually uses based on the unit you're cooling, because our larger unit, it's going to have to run higher, and also depending on how hot it is outside, it's going to have to run harder. So overnight runs, that's a big piece of why people want to go to 12 volts a lot of times, is just to be able to stay cool for sleeping, and this is going to do a fantastic job once it kind of ramps down to that 350 watt range. The exterior sound on this is fantastic as well. Just walking around their camper, this makes so much less noise and so much more pleasant sound than the unit on our camper. It's also quite lightweight. I think it weighs in at 57 pounds or something. It was really easy to pick it up and actually place it on the roof. Compared to some other units, it's probably actually going to drop some weight on the roof of the rig as well, which is always a pleasant surprise. Overall, there's a lot to like about it. I think it's a pretty good unit for the price, and I would definitely recommend it if this is what you're looking for. If you spend more time off-grid than on-grid, I definitely recommend this unit. If you spend time on-grid but you want the flexibility, this could still be a great option. With its efficiency, the conversion losses on charging your batteries to run this might actually make sense, but you are going to be putting a load on the converter and basically heating up and wearing out another component just to use this when plugged into AC power. Something to consider when thinking about a DC unit. Overall, it does what it says. It's quiet and efficient. As always, thanks for joining us here on Morton's on the Move. Be sure to hit that subscribe and like button. Also, head over and subscribe to our newsletter on our website. We always send out updates when we do videos like this. Your subscription helps us to be able to continue making videos like this. We hope to continue to test new air conditioning products as they come out, as well as share our adventures. Stay safe, and we'll see y'all down the road.